Okay, just a moment. So let's open the Nx. So new file as usual, model, name, and so on. So far, just we discussed all the options of the in the group of the direct sketch here in the top left side, and from today we will start to analyze all the functions in the group of the future. Here it includes creating the datum planes here. It is very important. Datum planes, datum axis, the datum coordinate system. So also, today we will see the extrude and revolve function and making the holes, making the pattern, the future shell, edge plane, chamfer, and here if you open there is a lot of functions. That's here the call it as a group design feature. So we will see from the today these features. It is call it is the group is to call it is the future group. So anyway, in order to do this kind of elements, we have to firstly make a two-dimensional sketch for the beginning and select the plane. So let's start with the sketch. Okay, select for example this plane, press OK. For example, I can draw the rectangle here. Can draw the rectangle, and I can make the extrude function here directly, or firstly make the finish. And here you see our rectangle is ready, and we can make the extrude here function, and here you have to select the curve where you want to make the extrude, and in the direction you have to select the direction vector in which you want to make the extrude, but in the default it is the always will be normal to the surface, so it is the will be in this case along the z-axis. So there is also the limits values, so start point, and let's change it endpoint. So we will see these groups also, and here we have the boolean. So we have the several options for the boolean, so we will see all of them, and directly we can make the draft for the extrusion. So the draft, then offset function we will see, and always a setting. So let's start for the beginning. So firstly you have to select the curve. In this case I will select my rectangle. So you see it starts to will be the solid element, three-dimensional element. So it will start to be featured extrude. Here you see this arrow represents the dimension of the. You can by the dragging you can increase the value or change the direction in the downward direction. So also you here the reverse direction. Directly you can reverse by the clicking this arrow upward and downward. So this is the how it's obtained. And let's make the upper. You see here the values. So start value is this the plane where we draw our rectangle with this orange one. So it's the start value. Is now it is the 0. You see from the 0 it starts to the end value is 27. You see this. Sorry. So start value this plane is 0, and the end value is you see it 27. The 8. So start value is this plane 0. So we can change the start values. For example, let's make it 10. You see, after this sketch, after you sketch, it starts after the 10 millimeter from the sketch. The system starts to be the extruded. Since here we have 10, and here this value is the 27. So total height of this system will be the 17 in this case. 27 minus 10. So also we can change the values for this one also. For example, 35. So it increases since here we have the 10 from the here and 35. Total the height of the system will be in this case 25. Also we can put the negative value for the initial one. Let's make it 10 minus 10 millimeter. In this case, you see it will be start from the downward of the minus 10 millimeter from the sketched rectangle here. In this case, total length, just a moment. In this case, total height of this solid element become 45. 35 plus the 10, so it will be 45 millimeter. This is the how and this limit values is start and end value is the work. So if you open here the start value, you see several options. So symmetric, until next, until selected, and so on. Also for the end values, we can the same parameter. So let's make it 0 in the initial position, and let's make it 30, and see other options here. Make the symmetric. Let's put, if you make the symmetric function, use the symmetric function, you see our the block increases symmetrically from the sketched rectangle. It means 30 millimeter upward and 30 millimeter downward. It means the total height of this solid element, extruded element, is will be the 60 millimeter. So this is the how symmetric function it works. So this is the how symmetric work. We can press OK in order to obtain your solid element. So let's see with the other features. So in order to do this, let's sketch. Let's make the, for example, the datum plane at a distance. We will see how to create the datum planes in the coming lecture. So this is just I am using for it. So we can create the datum plane at a distance of the set 85 here. You see, press OK, and I want to draw the circle on this datum plane. For example, in the middle, with the any dimension. Finish the sketch. So you see, circle is created. I want to extrude this circle. I want to extrude this circle until the surface that intersection with this solid block. So in order to do this, I will go to the extrude again and select my circle. So I will change you can change the direction just by double clicking this blue arrow. Double click, you see the direction is changed. Also you can change the direction from here in the reverse direction, and here let's keep the start value as 0, and let's make the end value, for example, here until selected. You see, if I select until the next, the system directly extrude this circle until this surface, so until the intersection of this surface. So we can make the preview it. You see, this is the how limit value until next is works. This is the limit value until the next. We can do with the until the selected function. So in this case here, select the object. We have to select the object where you want to make the extrusion of this circle. In this case, I will select this surface, or you can select the lower surface. You see, it is extruded until the lower surface. It does not matter. You have to select any surface. For example, I select this one. Now it is the extruded until the selected. This is the how until the selected end limit works. So you see, it is it is the extruded until the here, and here in the boolean you can use here unite function. So this block and this circle will become here the same element with the same parameters. This is the how the until the selected end value and limit works. So it is important to select the surface in this case. So otherwise this the function doesn't work for it. Until the extended, so until the extended the same, until the extended is same, so you have to select the surface here. You see it is the extruded until the selected until the extended function. So in this case for the block. So in the case of the last one, it's a through all. It means that this circle will be you see extruded until through all the object. It is the mostly used in the case of the making the some holes on the element. For example, you can make the subtract. You see it is the through all subtracted from the solid element, that is the block in our cases. We can make the preview. You see makes subtraction this circle through all of the this block element. So this is the how through all and value is the worked. In other the cases, for example, with the value also we can make the subtraction. For example, until the here, not the through all, but just until the here. In this case, we can make the subtraction here until the here. You see, not a through all. There is no hole here. We can see from the here view and edit section and this value. You see the hole is the created just until the this middle distance and so on. You can make the hole more the deeper and so on, and giving the any value. So if you want, for example, the change value of this feature, here you see in the part navigator, this feature is demonstrated. You can double click here and you see the values created, and we can change the value, for example, like this through all, making this through all, and the preview. You see it is demonstrated. Also, for example, if you want to change the sketch value, in this case not the future, here the future, and this is the sketch. So if you want to change the values of the sketch, in this case circle, here you see this sketch is created in the part navigator, and just to double click it, you see you go to your sketch. Here you see the value is this value. You can change the value, for example make it 20 and close it. And if you make the finish the sketch, you see the sketch is the changed. Also corresponding feature is the changed. It is the value, it is the 20 millimeter. This is the part navigator is the important. So you can control all the parameters here and change the values using the part navigator. So this is the what is the end values, limit values, and some here this values is the explained here. So with the until the selected, this all the end limits. So also here I explained what is the boolean. So we can make the unite and we can make the subtract. Also we can make the intersection. What does it mean intersection? So it means that this one. Here we have this cylinder and here we have the block. You see in the middle there is, you see from here to here we have the intersection. So if you want to remain the intersection between the cylinder and this block, we will use here the intersection function and select here the intersection with this block, and if you make the preview, you see only the cylinder remains. That is the height is the height of this block element. So this height, it was the 60 millimeter. So the height of this cylinder is the 60. So it is the remains just intersection between two solid elements. If you want to check this value, the distance, you can go to the analysis, then measure the distance. So distance between this edge and this edge, not the center. Okay, you see it is the 60 millimeter. So it is the direct exactly intersection between the with the solid element is the block with the block. So this is the how the system works. You can delete all of them. Just we can let's only keep the solid element, the rectangle, and let's make it just the value, and let's make it this one, let's make it 0. So if you have the rectangle here, let's open the extrude feature. If you have the rectangle, also here we have seen the limits. So boolens we have seen. We have also the function of the draft. So open the draft. In this case, there is no draft. So you can make the draft. For example, start limit, method of the start limit, and the key here put the values. For example, 10. You see the rectangle becomes some with the inclination. You can see here on this direction, in this direction, positive angle and the negative angle. Let's keep it positive. So press OK. You see, you can make the draft. It is just a simple draft, but in the future we will see here the draft function, exactly draft, but it is the more advanced draft than compared to this one. There is the several options to make the draft. We will see also. It is just making the draft with the extrusion function. Here we can see some filters, and here let's make it a face and select faces where you made the draft. For example, this face, this face, this face, and this face, and go to the view, object display. I would like just to make the color for the draft in order to see the result better. You see the sides of our block is drafted. See, this is how to make the draft. Simple draft. This one is not advanced. So let's select sketch. One more thing, you can make the draft with the cylindrical element also. For example, let's draw the circle and extrude it. Here no subtract, but just known. And let's go to the draft. You see the draft is created for the cylindrical element on the positive direction, or you can make it in the negative direction like this. So press OK. So and select the face, view, OK, object display. So this is how the draft is obtained for the two elements. Okay, let's go home again, sketch. In addition to the draft, there is also one more function. Let's select the plane. One more function in the extrusion. It is called the offset. So let's, in order to do this, let's sketch again rectangle. Here you see offset. Here still is inactive, so we can make the offset. This is in the single-sided in the two-sided or in the symmetry. Let's see in the single-sided. You see the system is the enlarged. You see that's the known. You see let's look here. So it is the enlarged from the all the sizes to the 5 millimeters offset. So we can make it 10. And let's see from the top. You see this is the orange is the original, so original rectangle, but with the offset of the 10 millimeter, it is increased. You can increase it more like this. So this is the single-sided offset. So also we can make the two-sided offset. You see here. So two-sided offset. You see here the values is the minus 25 from this side, minus 25 from this side, and here for example 40 from this side, two-sided with the different values. So we can say it is the asymmetric offset, and there you have the symmetric offset. So from the two sides is the same offset. This is the how the offset function works. So in the case of the extrusion, last command for the extrusion. Last command for the extrusion is the converting the solid element to the converting the solid element to the sheet metal. So let's draw this again the rectangle and also make the circle again. So let's extrude both of them in the same time. And here in the setting, let's open the setting. We have body type. They could be the solid or sheet. Now it is, you see, the body type is a solid. There is the full of the material inside it is the hard element. So we can convert to the sheet as a surfaced element. You see, it will become open element. So we will see this is how the surfaced element. We will see this kind of systems later. So you can convert directly solid elements like this into the sheet element. So this is the how it works. So convert the solid elements into the sheet elements. So with the same values, such as the surfaced element. So is it clear the extrusion function? Okay, good. So let's go on. There is if you expand here extrusion function, there is the revolve function also exists. So it is the used in order to obtain the solid elements for the asymmetric element or axisymmetric element. It means that symmetric element along the center of the axis. So by the revolving them in the around the center of the axis. So let's open the new file. Okay, sorry, new file. Press OK. So let's draw the one more the sketch for the beginning as usual, selecting the plane. So we can use the profile. For example, let's draw the such kind of things. So is ready. Finish the sketch. So I want to obtain this kind of the element with this sketch by revolving it around the center of axis. So I want to revolve it around the center of axis in order to obtain the solid element. In order to do this, I will go to the here, expand the extrude function, select the revolve function. So here it is the section, it is asking select the curve. So I will select my curve here. My curve is selected. So here later now today we will see also this function. So here it should be the connected curve is the better, just to select all the lines in the same time. Here you see in the axis, you see the specified vector. You have to specify the axis of the rotation of the vector. So it is let's say keep it rotating around the z axis. You can select this one also, but we will see it. So let's say firstly I want to rotate around the z-axis. Also you can select here, but let's select this one. So specify the point. Okay, you have to specify the point. In order to do this, open the point dialog. Here you can specify the point with the different methods. Let's keep its cursor location. So let's keep it here. Select this point. So I want to rotate it around this axis. So press OK. You see it is the rotating, and we can OK. So let I make some view. Sorry, not this one. You see this was my cross section area, and I rotated it. Here we made some mistakes since the point is in the little bit shifted. That's why here was, let's delete it and make the revolve again. So curve, vector, and here let's select maybe other, and point is the better here. Okay, and point directly on the dead position. So press OK. Now it's correct. You see here, you see around my cross section here, this is the cross section, and around this axis it is the rotating to the 360 degrees. It is the rotating into the 360 degrees. So you can change the revolve value. Here is the here it starts from the 0 and ends to the 300. So you can make it, for example, 180. It will be half. You see you can increase or decrease the rotation angle. This is the how revolve function it works. So this is the how revolve function. Since I revolved the system around this axis, also we can revolve it with some gap. So in order to do this, let's delete this one. So I want to revolve, for example, in the around the z-axis in this case. So in order to do this, let's again revolve, select line, and specify the vector. So in this case, I will okay. In this case, I will select this one. So you see, it is the rotating around this z-axis. So in this case, so you see in the middle there is the hole, creating the hole. Since there is the gap between this line with this axis. So here there is this distance. Let's measure the distance between this one in order to define the radius. So radius is this value. So diameter will be the twice. So here the radius is around 11.5 millimeters. So we didn't put the dimension. So this is the how the revolve is working. So is it clear how the revolve is working? And important things that when you work with the revolving features, always you have to draw firstly like the cross section of the element. Then you will define the revolve axis in order to obtain the revolved feature. Always work with the cross section. So is it clear the revolve, students? Okay, let I open again a new file. I want to explain the extruded features filters. There is exist some features for the for example, let's draw the simple rectangle and finish sketch. Since as soon as possible, when you activate the revolve feature, extrude feature here, activate revolve extrude feature, you see here new filters is the generated here. Since I deleted, you see there is no. If I activate extrude, this is the filters for the extrude function, the selection filters. There is several options: single curve, connected curve, tangent, and so on, region, and so on. Let's see, analyze the some of them. Because it is the important when you making the extrusion function. For example, in the single, which I select the single, and here I want to extrude this rectangle. So in the single curve, if I select the rectangle, you see, just let's make it lower. You see, if I select the rectangle side, it only selects the single curve, only this side, and with the height of the 20 millimeter. The same way, if I select this one, and this is the selected. Step by step, you can select, and as soon as possible, I will select the last one. It will become the closed element, and it will become solid element. What we have done so far. This is the how to extrude with a single curve. So next is the connected curve. Connected curve. So in this case, in the connected curve, if I select one side, it directly makes extrusion all the connections, like we have done so far directly, because all the four sides of the rectangle is connected. This is the how the connected curve works. For example, if I have another element in the system, like here, for example, let's draw and make like here. So if I have such kind of system and I want to extrude it, for example, let's make it with a single curve. And here you have activated the stop at the intersection. Let's activate it. It means that if I select this one, you see it just extrude until here, from here. Since we have here the intersection and I activated this intersection, it will just stops here. The same way, if I select this one, it will extrude until here, because I have some intersection stop activation here. The same way, I can select step by step all the things, so I can make extrusion function like this. We can change the direction, and if I want to extrude this other part with a different height, I make that here the apply. You see, apply, and you can use the single curve or other one. For example, let's use the single curve to extrude this one. So I select this side, this side, this side, and these sides also, to make the closed system. You see, it is the increased, and we can make different value. And here, let's make the unite and press OK. Okay, this is the how efficiently work with the extrude filters. So let's delete this one. Also delete this extrude. Open the extrude again. Here we have the other option, that is the more commonly used region boundary. And the region boundary, if you go to the DC, it will select regions by region. So I select this one and press apply, and I select this region. The same result is a different methods with the region boundary. So there is also now this is the infer curves. So in the infer curves, let's firstly delete these two. Extrude and the infer curves. So if you select the line, it directly extrude all the existing lines at the plane. In this case, it will be rectangle. You see, it will be rectangle. Since this one is also extruding with the same height, there is no, you cannot make the different height in this case. So this is the how inferred curve is obtained. It extrudes since this rectangle and this element is in the same plane, the drawn in the same plane, so it extrudes at the simultaneous way. Also there is the we see connector. So here we have tangent curve. So since we don't have the tangent, since for example if I select this one, here we have the tangent curve, so it will select directly this whole line because here we have the tangent. If I select this one, only extrude this one because there is no tangent for the this curve. Here we have the tangent curve, so it selects all the line directly. So I can extrude this one and making the rectangle. So let's keep the boundary. So let's increase this one. Since we have the extruded feature, also we can make some extruded feature for this one, making them here feature curves. So select again this one, and you can draw the lines here or some sketches in order to extrude additional extrusion. So this is the how the extrude function the filters. So others we will see the with the here the with the phase systems and the sheet systems. We will see others in the with the other section when we talk about the surfaces and sheet metal. So this is the mostly used the single curve, connected curve, tangent, and boundary and inferred curve with the solid elements. Okay, is it clear that this way? Because it is a very important tool in order to make the more efficient drawing. So is it clear the filters of the extrude function? Okay, good. Okay, if the clear, let's make some practice with the extrusion. So with the revolve also. Okay, let I open the file. Okay, we can start with this one. Okay, we can start with this one. So let's open the Unix and make the new file. Press OK. So we can, for example, draw the firstly this element in the upper side. So here this is the radius is 18 and this is the diameter is the 18. So diameter will be here the 36. So let's draw the this side. Press. Okay, let's draw the circle, two circle with the diameter here the 18 and the bigger one is the 36 and here the distance from the center is the 30, the half of the 60. let's define it. And let's make it a mirror using the mirror function. Select both circles, and here the select the center line, select this line, so press OK. Now using the line connect this lower part and the upper part. Here also we have the second line, sorry. So you can draw the line here firstly and make extend to be like this. You can use the different way. So here distance is the 12. Is the 12. So now we can extrude it, this distance, so we can extrude it. So it's the 36. Let's finish it. So I want to extrude it with the help of we can extrude with the boundary, for example. So this one, you see, with the boundary to boundary. So let's dictate it here, and this one, all of them is here the 36. So you see this element is creating this one and this one, this one. I have to obtain now this one since it is the 12. So 36 minus 12, so this distance, open distance, is 24. So let's firstly apply it, and now let's make the boundary of this one. So you see it is the extruding, but in this case I will make the starting point 24 because the 36 minus 12. So you see my system here, let's make it the end point is the 36 because it ends with the same distance of the here, you see. So make unite between this value. That's okay. So we can hide this value. You see, it is easy using with the filters and so on how to obtain the upper part, this one. Now we can go to the lower part here. We can draw this one firstly with the rectangle. So in order to do this, let's here. So here is the distance. Let's draw the okay. We can draw the on that side and extrude to this side. So distance here the 25. You see distance from the here to here, starting point to 25. So we can make the here the datum plane, create a new datum plane at a distance from this side. Here in this side is 25 millimeters. So we will learn how to create the datum planes. So you see from this surface, 25 millimeter datum plane is created. Press OK, and we will draw the rectangle on that datum plane. Sketch, select a new datum plane. So let's firstly draw the rectangle here. So let's put it is the dimensions. So this is the 2660. So let's here the 60, and this is the 12, so 60 minus the 12, it will be 48. So the here this distance is the 48. Okay, it is the exactly 48, so that's okay. And this is the, we will move here, and let's define the dimension between the here is the 0, so it is the same exactly. And the height of this one is the 25, 12, 12, 24 is the, this is the height is the 49. If I make some mistake with the dimensions, so let me know. So 48. Now let's draw the lines here firstly. It is a little bit inclined. Don't worry, we can make it, it is the constraint, so make the horizontal, this one and this one, and let's define the dimensions. Here is the 12, 20 and 12, 12, 25 and 12, so rapid dimension. So the distance here to here is the 12, and the distance here to here is the 25. And sorry, just a moment. Okay, where is the another line here? What? 74, the height. Why it's 25, 12. Sorry. Sorry. Yes, correct. 74, yes. That's why just I made. There is some again. 74. Correct. Now it's correct. Now we can define this point is the 12. Sorry. So now I can extrude it using the boundary again as usual. So let's, in order to finish it, extrude it step by step. I will extrude it, for example this one, and firstly let's make it 0 starting point and reverse direction, and let's see, here is the 25, lower part is the 20, here at the end value 25, so here the known should be okay, apply, and the next region, this one is the reverse direction. Here we have this one is a 12, this one. Okay, in this case we can make the unite with the lower part, it's the boolean, apply again, and this one, so here okay, unite with this one, and the distance is the, again this one is a 25, so 25. Just a moment, let's make one more time. Here go to the boundary, this one 25, and with the unite with this one, apply, and one more upper here. Let's first know it is the, again the 12, this part. Just a moment, I didn't calculate it, but let's here 12 to 25, and yes, here here we have yes, here 18, and I mean just a moment until No, here we have just one. Let's calculate it. Here we have the 90 until the here, and this radius is the 18. Yes, it will be 72. Yes, I wrote 74. Yes, yes, I will check it. I will correct it. Here is the 12, and just apply it. You see, now it's obtained. Let me the correct the height is the 2072. Okay, I corrected it. And did you understand how I obtained this one? I didn't make the unite this one. I unite with this one. Okay. So this is the how I obtained this one. We can hide this one. And also let's keep it for. So last step is to obtain this rectangle. In order to do this, we can here also we have this one. Firstly, let's obtain this rectangle. We can do, for example, draw the rectangle here. In order to do this, let's sketch, select this plane, press OK. So here we can using the profile draw the rectangle from this position to this position and draw the here. Always it should be the closed system. In the case of the extrusion, let me check if I am correct or no. So I draw the rectangle here and I will extrude it. You can use the boundary is the better. So here is the distance, it's the 12. And here in the boolean, let's directly unite with this system. That's okay. No toolbar is okay. Just a moment. Let's make it known. Now it's okay. Then since we can hide this one, this system and this systems all is not united, we can use here the unite function. Also you can unite this one, and just a moment, you can unite this one with this one, apply. No, I don't know. Here here should be this sketch. Where is the sketch? Here. This is the until the end. I think that here we can correct it. Okay. Just a moment. So just a moment. So now I can again extrude it, finish. So it's already extruded. So let's hide this one. Now this is the system, how it looks like. So I can obtain this hole here, this hole. In order to obtain the hole, I can draw firstly the rectangle, and let's define the dimensions. Here is the 9, and the height is the 16 because the radius. This is the 9, and this is the 16, and here we have the distance 25 and 22. Let's define the location of the rectangle. Distance from here to here is the 22, and from the bottom is the 25. So then can make the arc here. We can trim these parts using the trim function. Okay, now is the fully constrained system finish. We can make the extrude. Sorry, there is the intersection with this one. Maybe we with the mistake with the here 25 is from the middle. Let's change it. It is delete it and from the middle. Okay, now it's correct. Can finish. Now it's correct, you see. So we can make this here in the boolean the subtract. Select the element, subtract from this one, and press OK. Can hide this one. So also hide this one. So this is the this element. So we finish it with it. So let's continue with the second exercise. It is related with the revolve function. Let I open it. Where is it? It is related with the revolve, this one. So let's do this one, then we will finish. So I opened a new file. Is it clear the every step here? You can practice by yourself. I will share the recorder as well as sketches. You can make the practice by yourself. So let's open a new file again. Press OK. So let's sketch. We can use this plane. Press OK. So I don't know why I like this. So okay, here we have to obtain this element. Here you see cross section of this element. As I said before, always we have to take care about in the revolve function. On the firstly, as a first step, we have to draw the cross section of our function. So we will draw this cross section. You see, in this shape. Put all the dimension as demonstrated here and revolve around this axis until 360 degrees in order to obtain our shape. So let's start with the system. So we can use the profile and draw this one. So just a moment. Okay, let's close this one in order to obtain this one. So we have such a system. So the So let's extend this one and make the trim this unnecessary. So I draw the main shape. So let's put the dimensions. So here we have the 16.5 diameter. So the distance from this position to this position will be the half of this one. So let's define this one. So distance between this one and this one is the half of the 16.5 divided by 2. So this is the this value, and let's define the other value. So here next value is the this one. So here we have this value is the half 60 half of this value 60 36.5 this value 36.5 divided by 2. Next value is this one. So this is the half of this value, this diameter, 68.5. 68.5 divided by 2. Last the diameter is this one. It's the half of this value, 96.5 from the origin. Okay, 96.5 divided by 2. So we defined all the parameters with respect to the center of axis. Now let's define these values: 12, 44, 10, and 12, and here we have also 12. This is the 44. This was I think the 10, and this was 12, and this was also 12, and this was, sorry, this is the over constrained. It's enough. So finish the sketch. So the cross section is ready like this. So we can now revolve it. Go to the extrude, open it, revolve it, select the curve. You see all the selected. Specify the vector. In this case, this vector. So you see it is the revolver around the center axis. So it in the 660 degrees, 300. So the system, how its revolve function is obtained. Next step is to make the holes here. You see there is the through holes. So in order to do this, okay, go to the sketch again. So select the plane, press OK. So the holes is located in the angle here. Let's draw the first circle to locate the holes with the diameter of the 80. Unfortunately, I forgot to give this diameter, so I will correct it. So make it reference. So draw the hole here with the 8 millimeter diameter circle, I mean, and locate it here using the point on the curve. This one with this one with the x-axis also. So it is located. So number of the holes is the 1, 2, 3, 4, 5, 6, 7, 8 number. So we'll make the pattern curve. Select this hole, circular pattern, specify the point this one, and number is the 8. You see 8 holes, 8 circles is created. Finish the sketch. So you see, let's hide this one. Now using the extrude, we will make the subtraction. Here the change it as a inferred, because if I select the one hole, all hole will be selected. You see, it is the, let's change direction and make it subtract here and press OK. You can hide these ones. So this is the how is the system is obtained this element. So that's all for today, students, and we can finish. So we will see on Monday. For today, we can finish now, and have a nice weekend. See you on the Monday. If everything's clear, okay, okay, you are the welcome. See you on the Monday. Have a nice weekend.